Magnesium is integral for 600 plus biochemical processes in the human body, and yet most people are deficient. Common signs of magnesium deficiency include fatigue, muscle weakness, stunted growth, poor immune function, poor concentration and memory, hormonal imbalances, bone and teeth problems. Most people think grabbing a bottle of whatever cheap stuff on the shelf or at the top of Amazon will solve this. The common misconception is that consuming more magnesium will automatically improve health and well-being. The truth is, there are various forms of magnesium, each of which is essential for a variety of physiological processes. Most people are deficient in all forms of magnesium, while even those considered healthy typically only ingest one or two kinds. Consuming all 7 of magnesium's primary forms is the key to accessing all of its health benefits. That's why we pack 7 forms of 450 milligrams of elemental magnesium into each serving of Wild Mag Complex. 1 dose a day is all you need. Learn more and grab a bottle today at wildfoods.co. Use code GENIUS for 10% off your order. Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers, because once we do, we'll be able to put a donate button, and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD, and working on a product to help people overcome these problems, because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. Thank you for coming.
Thanks for having me.
What's your current research about? What kind of questions are you looking to answer?
So I'm mostly interested in microplastics and ways that we quantify and monitor for microplastics, particularly in freshwater ecosystems. So I primarily study lakes and streams or creeks. I'm also interested in how people perceive waste and plastics issues and some of the misinformation that surrounds those issues.
Okay. Specifically, what are you trying to figure out about waste and plastics? People's perception of it is incorrect, or what do you mean?
So a little bit of everything. So I'm interested in how we kind of inform circular economy approaches with better data. So when it comes to like human behavior, like what kind of waste do individuals generate is kind of what I'm interested in with some of the surveys that one particular survey that we put forward with an environmentally oriented group, as well as when they were asked about different questions related to plastics and waste. For example, the existence of, trash islands in the Pacific gyres, whether they believed that was true, how much they agreed with that statement, and then comparing those answers to what's available in the research and also what's available when people do popular searches on Google.
So are you looking at what trash people generate themselves, or you're looking at their perception of what they think others generate?
So both, not what they think others generate, but what they personally generate. So this was looking at specifically a social media campaign called Futuristic February that used to be put on by a group called the Sustainable Duo on Instagram. And we did an after event survey of that population just to get a grasp of their environmental perception. So how they perceived the environment and how they interact or have that place in the environment, as well as the waste that they generated, and then how they perceived different plastic issues or waste issues.
So what are some of the interesting answers you got on, relation to the Pacific gyres, the garbage patches, et cetera? What kind of data from the services is interesting?
So I think my probably most interesting finding for myself was that people were the most uncertain about questions that had to do with either biodegradable plastics or bioplastics. And they were 100% in agreement, whether they were like slightly agreeing or fully agreeing with the statement that microplastics are toxic, which was very interesting because that's still a highly uncertain field of research currently that people are still trying to look into, especially when it comes to human toxicity. So I thought it was really interesting that, and kind of lends itself better to where do we put like educational efforts about certain materials, because clearly it's possibly lacking when it comes to people's perceptions of bioplastics and how they think of them and what they are supposed to do with them.
Well, if we don't have data on microplastics, people assume that they're harmful, then what would be your approach?
That's a good question. So I guess it's not that you want people to think that they aren't harmful, but the data is still uncertain about it. So I think the approach would be that we need to probably communicate that uncertainty a little better, especially in popular media, because I think when it comes to headlines that get people to, read an article, it might be more interesting to be very certain about something, but it is more factual to kind of display the uncertainty behind what's going on with the current research and communicate that a bit better, I think, to scientists and non-scientists. So scientists within and outside the field, as well as non-scientists who are reading the article and just trying to be up to date about microplastics.
At this point, if toxicity is not known, then what can you say except that, research is in progress, but we don't know?
Yeah, I think there's some things to be said, particularly with findings attributed to biota. But I think the human research side can only be kind of inferred from other studies on similar materials. And I think it's challenging. I'm not myself a toxicologist, so it's a little bit more difficult. I think I can't really speak to the impacts, but the majority of my research has been on quantifying and detecting microplastics in the environment.
So let's talk about some of that. What sizes of microplastics are you able to get data on? What kind of instrumentation do you use? Can you get to the 1 micron or submicron level?
To study microplastics, to my knowledge. So we kind of had to develop a way with the equipment that we had available. So I primarily do visual identification. So using a stereo microscope to visually identify microplastics and then subsampling them to determine, is it a microplastic? Are we certain? And what kind of material is it possibly? And so we can usually get down to 100 microns in size. That's kind of our cutoff for saying, like, are we more certain or uncertain that this is a microplastic? And we use kind of a guide that we've developed to determine, do we think it is a microplastic or not?
What would it take to get down to 1 micron?
That's a good question. I don't particularly know. I know that there's a lot of different methods to do that. Some of them are like filter scanning methods using Raman microscopy or Fourier transform infrared spectroscopy. More time-consuming efforts and looking at like the whole filter versus we're only able to look at what we can visually see. And there's also some other methods that people have put forth that are more mass-based instead of based on like count or number of particles.
Well, aren't there like standard filters that you could run, a liquid sample through? And if it had a small enough pore size, it would catch, whatever debris in there. Then maybe you could do, FCAR or maybe gas chromatography or something, liberate the materials off the filter and then see what's in there. Would that be maybe a backwards or a, around the way method of getting to smaller sizes than 100 microns?
I mean, yes, that is what people who can detect that low are doing. We do the same thing. We use like a small filter pore size, but we just don't have access and just didn't have the time to do that. But visual identification is still widely used in the field. And it is, like, for what we were doing, probably the way to go because we had a lot of organic material present in our samples. So it would have been difficult to, one, eliminate the organic material enough to be able to filter scan without having to move material on the filter, which is primarily what we had to do. But I think there's still some efforts to go forward with how we're able to detect with so much organic material present in the sample.
Yeah, the reason I ask is, I would think larger pieces, 100 microns plus, wouldn't get lodged, let's say, in the gill of a fish, or maybe smaller tissues, or maybe the intestines of a person. I would think, and it's just based on breathing in, air pollution type material, that the 1 micron size is like the sweet spot, if you call it that, for causing real problems with biological systems and creatures. That's why I asked if you can get down lower. I wonder what you'd see.
Magnesium is integral for 600 plus biochemical processes in the human body, and yet most people are deficient. Common signs of magnesium deficiency include fatigue, muscle weakness, stunted growth, poor immune function, poor concentration and memory, hormonal imbalances, bone and teeth problems. Most people think grabbing a bottle of whatever cheap stuff on the shelf or at the top of Amazon will solve this. The common misconception is that consuming more magnesium will automatically improve health and well-being. The truth is, there are various forms of magnesium, each of which is essential for a variety of physiological processes. Most people are deficient in all forms of magnesium, while even those considered healthy typically only ingest 1 or 2 kinds. Consuming all 7 of magnesium's primary forms is the key to accessing all of its health benefits. That's why we pack 7 forms of 450 milligrams of elemental magnesium into each serving of Wild Mag Complex. 1 dose a day is all you need. Learn more and grab a bottle today at wildfoods.co. Use code GENIUS for 10% off your order.
Yeah, I mean, I wish I could tell you, but we don't go that far down. Still, because of like what we're able to detect and what we can see, there is still a lot of importance to the larger materials, because a lot of these materials will end up becoming the smaller materials, just based on how pervasive, persistent microplastics and plastic materials are. They will become those smaller materials. And being able to characterize the diversity of those larger particles can go a long way, I think, into developing policies that can kind of target the sources of where those microplastics are coming from. And as they become smaller, it's much harder to determine where they likely have come from, because their shape kind of changes into, a microplastic sphere or microplastic bead might become something that looks much more like a fragment, and you can't really tell what the original material was other than the polymer type. But when you're at that larger size of seeing, oh, that is a microplastic bead, you might be able to say, oh, that could have come from a personal care product, an abrasive, a cleaner, and there's more actionables that you could use that for. So that's why I think still plenty of importance to looking at the larger materials as well.
What are some of the sources that you're sampling to get microplastics information?
So I'm characterizing microplastics in 2 lakes in central New York, as well as one of the lakes, Onondaga Lake's tributaries and outlet. So we're characterizing microplastics that are present in the surface waters typically, as well as in the lake water. We haven't been able to characterize because one of the sources to our ecosystem is combined sewer overflows, as well as wastewater treatment plant effluent. And due to COVID, there were some restrictions in whether we were able to get source direct materials, but we're primarily sampling within the ecosystems themselves rather than a particular source.
So what are you seeing when you sample? What's predominant, fibers or spheroids, or what do you see?
So typically fragments and fibers have been the most prevalent microplastics that we've seen. And then depending on the location, those can kind of change. But the most dominant material is usually polyethylene plastics.
So where does polyethylene come from primarily?
It's used in so many things, especially because we characterized both low density and high density, because they're very difficult to separate spectra-wise with the FTIR. We kind of lumped those 2 categories together into just polyethylene. So that makes it a little bit more difficult to tell like where it would come from. But I think food packaging is pretty common. I think plastic bags as well. but that would also be more indicative of like a film morphology, which we didn't see as much of, but we did see some.
So can you now go back and sample directly from the wastewater treatment plant and other sources, kind of subtract them from the things that you're seeing in the lakes and streams?
I'm like finished with my field sampling, so I won't personally be doing that. But I guess in theory, somebody could do that. Yeah.
Well, I guess then you'd know if the wastewater treatment plant contributes most of the polyethylene or if it's some other source that contributes it. It just might be a good follow-up in the future, but someone else would have to do it to subtract out those point sources and see what's contributing to what.
Yeah, I guess someone could definitely do that. I think there are so many diverse sources that enter our ecosystem that it might be difficult to characterize all of them, but I think it's definitely worth doing, especially with the amount of combined sewer overflows and just looking at street litter and things like that. I think that would be an interesting follow-up.
Did you do sampling over time? Like how short was the window of sampling and how many samples approximately?
So we sampled over a 3-year time period with different types of sampling methods to test a limit of detection approach with quality control to see if it would improve capture and also what microplastic diversity looked like using different methods.
So what was like the average number of particles or things that you found in a water sample, again, given a per volume basis?
I don't know the exact value for all of the samples because they varied quite a lot, but I think typically in Onondaga Lake values were higher, especially for one of the samples we collected post fall turnover in November 2020. We had a pretty high concentration compared to some of our previous sampling. And then we saw that concentrations in 2021 were much lower. And then we also tested Skaneateles Lake, which is the source of unfiltered drinking water. They have a filtration waiver to use that water for the city of Syracuse. And we did detect some microplastics as well within that lake, though typically lower than in Onondaga Lake.
So do you think there's a lag effect based on human activity? And maybe that's why 2021 was lower than 2020, because maybe the lockdowns caused a period of X number of months to have lower pollution inputs, and then they reflected months later when you did the sampling. Is that possible?
It is possible. I don't know that we can contribute one potential thing over another, because there were a lot of other factors that we think could have contributed to a lower concentration, especially because the flushing time of Onondaga Lake is quite fast compared to some other lakes. It's on the order of like 3 months versus some lakes, like Skaneateles Lake, it's around like 18 years. So that's another potential factor that I think would make something like the impacts of COVID, for example, you might notice that a lot sooner, and it might not last as long in a lake that flushes faster.
What about seasonal variation or different sampling points in the lakes?
Yeah, so we sampled different lake positions as well as different seasons, but we weren't able to get as many samples as we would have liked during more of the wet seasons. And we were kind of limited by when boats were going out and when we were able to collect samples, because there are certain seasons like summer and spring are typically better for sampling. So we weren't able to really narrow down if there was kind of like a seasonality to what we were seeing. We did consider stratification and kind of pre and post lake turnover, but we're still looking into that information to kind of see what the potential impacts of lake turnover might be.
What about the total biological mass in the water, of all the fish and smaller creatures? I would think in the summer and spring it would be much higher than winter. And perhaps then there was more consumption of microplastics by the living biota there. Any of those effects that you observed?
We weren't able to really consider that. We were primarily doing surface water rather than water collected at depth. So we wouldn't have been able to see those impacts as much.
I mean, there's certain algae, maybe they would be a proxy to the amount of life, in the rivers and lakes at a certain time, even though it's a surface sample, photosynthetic bacteria or algae. Any of those come into the samples, or again, you can't look at everything? It's just too much.
No, yeah, I mean, we couldn't consider all of those things. We primarily just collected the water samples, not any kind of biota that were present in the lakes.
When you did your sampling, were there any visual cues like large macroscopic plastics that were floating in the vicinity that were there or absent at different times you sampled? Like, when the sampling was done, did you guys look around and see literally what you were sampling? Where was the water cloudy at certain times? Was it, again, did it have visible macroplastics in it? Were there any, visible large differences when you did a sample in one lake versus another, in one location versus another? Was any of that written into the data?
Yeah, of course. We considered, what we could visibly see as far as if there was any floating debris or if there were macroplastics present. We did consider that, especially because we did sampling in the Inner Harbor region, which is one area in Onondaga County where they use skimmer boats to collect floatables, which includes macroplastics that float on the water as well as floating woody debris and things like that. So we did collect some samples there and noted that there were higher concentrations of plastic particles in those areas where floatables collect versus some other parts of the harbor where we didn't sample. There were obviously less floating material.
So what kind of conclusions did you draw from the data? What differences did you see?
Differences between the lakes, or what did we... Because we looked at a lot of different things. Our first kind of couple years of sampling was looking at different collection methods, because the field of microplastics is very unstandardized when it comes to collection methodologies. So there's not one particular way that people collect samples and everyone does it the same way. There's a ton of different ways and everyone kind of does it a little bit differently. So we looked at different methods, and we had started with kind of low volume sampling because it's easier and it's faster. And we kind of realized that with our particular ecosystem and what we're able to quantify at specific volumes, we weren't really getting quantifiable amounts of plastic. So after that, we kind of tried other methods. We tried bucket sampling with a sieve. We tried net sampling. And we kind of found that if you're using lower volume methods, at least where we were collecting, we weren't really capturing the full diversity of plastics in our ecosystem. And that could potentially be misleading for any regional policy that we would try to contribute to based on those results. So we found that net sampling worked the best for us in collecting the full diversity of plastics. But in areas where you're collecting a high quantity and there's a lot of organic material present, that could also be very time consuming. So we kind of recommend people implement better quality assurance and quality control protocols to first characterize what kind of background contamination they might have from, sampling protocols that they're using and the labs that they're using. And then afterward, they can properly determine how many liters do they need to collect in their environment to get a quantifiable amount of plastic, and then go from there.
How do you know when you're collecting that, let's say you're collecting in a plastic test tube versus a glass one, you're transferring a sample from one thing to another with a pipette, it's plastic, let's say. How much contamination can occur in a lab setting where you're trying to analyze a sample, or, from collecting it to analyzing it?
So it really depends on the lab and how small in size that you're going, because the smaller in size you're going, the more contamination you're going to have, especially from something like a plastic test tube, where we'd think that if you had any cross-contamination, it would probably be quite small. Whereas the primary contaminant that we had to deal with from our laboratory process and from our field process was microfibers. So that would be fibers from clothing that people are wearing during collection, lab coats people are wearing. And the way that you want to look at that is being able to quantify background contamination from the moment you start taking the sample to the moment that you're finished with the sample, and basically having a blank that's present throughout that whole time period, and also blanks that are there during laboratory processing. And so we kind of implemented both and kind of compared them, and also implemented improved quality control to subtract out any blank contamination that was occurring with our samples.
Yeah, because the pH of the sample, I guess, could leach microplastics out of a test tube or whatever other instrument, or they just might be coming out of them as well at a certain rate and contaminating the samples. And like you said, clothing in the lab, et cetera. Did you see any big signals of contamination sources?
So we commonly saw microfibers from our lab coats, but we dyed our lab coats bright pink to make sure that we knew what those looked like when we saw them. So we couldn't quantify, and we subtracted any fiber that looked similar to our lab coats to make sure that we weren't artificially elevating our concentrations. We also saw a lot of blue microfibers, and we're not completely sure where those came from and whether they were all plastic. Some of them looked more like cotton. So it's possible they came just from, the surrounding environment. More people potentially wear blue, but we did see a lot of blue. And just, anything else we saw within our blanks that could be mistaken or considered a suspected microplastic, we made sure to note that and usually subtract that out as part of the quality control process.
So did you see that just by wearing certain clothing, it released enough fibers into the air that they would fall into samples? Is that what you're saying?
Yeah, so it's possible that, one, it's part of just like the air contamination of just being around the samples. Even though we cover our samples throughout the whole process, it's possible that they're introduced through the air or that they're transferred onto either glassware or our sieve stack while we're processing the samples. And that's another way that microfibers are potentially introduced.
Well, have you done any sample handling under a fume hood only? With laminar airflow, maybe if it's available?
Yeah, we do the majority of our processing in a Class 1000 clean room. So that has like an advanced system for dealing with kind of air contamination that we would be subjecting samples to. And we haven't like directly compared what that looks like with some of our other hoods, but I guess someone could compare between different types of hoods and see what that looks like. But what we were kind of noticing is that there was certain trends of just seeing more microfibers. And so if other labs were noticing that or having that throughout their protocol, it would just be important to kind of determine what either the average is or look at better determinants of quality control, like the limit of detection or limit of quantification, which is something commonly used in analytical chemistry. So we were looking into using that instead of doing average subtraction.
Well, what about partnering with another lab so every sample that lab puts out, they send you half and you test it as well. And then you do the same thing. You send them half of a sample so that you can see amongst two labs, is there a difference? Maybe that's a good way of subtracting some of the lab specific contamination.
I mean, I don't know. I definitely think like intercomparability of different laboratories is very important to kind of see what contamination looks like, what are the differences. But when it comes to if you're specifically trying to do a blank subtraction with your samples, then it should be with the conditions and the laboratory in with which they were processed in, not an outside laboratory.
Well, then maybe you won't have to control for a lot of factors. You could see like, oh, these 10 samples, both our lab and, the other lab, the other school did it. And on average, we see, 20% more fibers than they do. So it looks like there's some lab specific signal. And then maybe you could tackle that way. Just another way, I guess, of subtracting.
I suppose so. I guess our focus was more on how do people that are monitoring for microplastics and want to possibly figure out what their specific contamination is throughout their process, how do they monitor effectively while also collecting the necessary information on any background contamination to make better quality assurance decisions going forward, and also producing data that is more harmonized within the field and can be more easily comparable with studies that are, in different geographic regions from them.
All right. So in your sampling, is there anything that jumped out at you that was a huge signal, or was it all pretty subtle, the results you got?
It depends what you mean by a huge signal. Can you elaborate?
Well, I mean, was there far more microplastics than you thought, far less, a predominance of fibers or a lack of them? Like, what are some of the things that, again, stood out to you in the analysis as either confirming your hypothesis or being unusual and something to investigate?
So we expected that the southern portion of our lake, which is primarily where a lot of the pathways for microplastic contamination into the lake would be coming in. So that's where our wastewater treatment plant is located on Onondaga Lake, as well as where two of the major tributaries, Onondaga Creek and 9 Mile Creek, come into the lake. So we expected the southern portion would be higher, but it wasn't always higher. And that we thought that was pretty interesting. And we're still looking into why that could be. But we did find that typically Onondaga Lake, which we thought would have higher concentrations, it's very urban. An urban lake versus Skaneateles Lake is more agricultural land use, mixed land use with residential areas to the north and some more increased recreation to the north of the lake, was typically lower in concentration than Onondaga, which was what we expected. We did think we'd have predominantly microfibers, but fragments were more common. And I think that's potentially because of increased inputs of street litter that could contribute microplastic fragments versus fibers, but also it was difficult with the contamination that we had on microfibers to always quantify them effectively. But yeah,
okay.
I'm hoping to transition into the field of sustainable materials management, just because I think seeing kind of the end process of microplastics and them in the environment, I kind of want to be on the front end of helping to stop the flow of microplastics from entering the environment. So how do we handle materials? How do we handle waste? Are there more effective ways to manage our waste and basically reduce our waste before it becomes an environmental problem or ends up in the environment? So I'm hoping to transition to that after I defend.
Okay. Well, very good. Thank you so much for coming on the podcast. I really appreciate it.
Yeah, thanks for having me.
Magnesium is integral for 600 plus biochemical processes in the human body, and yet most people are deficient. Common signs of magnesium deficiency include fatigue, muscle weakness, stunted growth, poor immune function, poor concentration and memory, hormonal imbalances, bone and teeth problems. Most people think grabbing a bottle of whatever cheap stuff on the shelf or at the top of Amazon will solve this. The common misconception is that consuming more magnesium will automatically improve health and well-being. The truth is, there are various forms of magnesium, each of which is essential for a variety of physiological processes. Most people are deficient in all forms of magnesium, while even those considered healthy typically only ingest 1 or 2 kinds. Consuming all 7 of magnesium's primary forms is the key to accessing all of its health benefits. That's why we pack 7 forms of 450 milligrams of elemental magnesium into each serving of Wild Mag Complex. 1 dose a day is all you need. Learn more and grab a bottle today at wildfoods.co. Use code GENIUS for 10% off your order.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.